Hello, Sleepy Traveller. Before we set sail into tonight's story, tell me, where in the world are you watching from right now? Drop your country or your city in the comments below. I love imagining this quiet constellation of listeners scattered across continents, yet all drifting under the same sky. Tonight, we'll be exploring Whispers from the Heavens, the tale of a colossal visitor, said to be unimaginably larger than what we've seen before. Astronomers have noticed its path curiously overlapping with that of another traveller you may have heard of, 3I Atlas. Some call it coincidence, others think it feels almost deliberate, as if the cosmos itself is arranging a secret meeting. Settle back, let your breathing slow, and let's drift together into the mystery of this giant object and its strange alignment with 3I Atlas. September the 12th, 2025. A routine sweep becomes a red alert. A bright trace appears where yesterday there was nothing. Not a hot pixel, not a satellite flare, not a ghost. A sustained streak across consecutive frames, lengthened just enough to betray motion. Analysts blink the images and the line moves while the stars hold. Rate, angle, certainty. Each number falls into place. Within minutes, the calls go out. A second instrument catches the same intruder on an independent track. Same sky tile, new coordinates. The signal to noise is high, the morphology is cometry, the residuals after subtraction are clean. The object is not faint. Initial photometry points to magnitude approximately 7, bright enough to reach backyard gear under decent skies. The startling part is the scale. A tail length that spans degrees, not arc minutes, cutting a visible slash through Virgo. Early estimates, roughly 2.5 degrees, about 5 full moons laid end to end. Numbers like that do not show up in raw discovery frames very often. The designation process moves quickly. A provisional tag appears on the circulars. Within a day, the IAU issues the formal name, C/2025R2, with the Discoverer credit tied to the instrument that saw it first. SWAN, the shorthand sticks. Professionals pivot schedules, amateurs roll mounts into gardens and fields. Northern and southern hemispheres light up with the same target, hours apart, all pointing at the same long luminous feature sliding inward. Imaging feeds multiply. Wide fields show the tail as a pale river. Longer focal lengths resolve a condensed head with a soft halo. Photometry tightens around a consensus value after corrections for air mass and moon phase. Spectral snippets arrive from small prisms and larger spectrographs, continuum-dominated frames with hints of gas lines riding on top. The chatter shifts from "is it real?" to "how is it this big this early?" Trajectory fitting begins in parallel. Each observer contributes time-stamped astrometry, right ascension, declination, uncertainties in arc seconds. The orbit solver ingests the sequence and outputs elements that sharpen with every additional line. Inbound, steep inclination, perihelion on the near horizon of the calendar rather than months away. The rate of motion curve starts to lift. Predictions for tonight slide by arc seconds from last night's list. Ephemerides update hourly. The sky has moved from rumour to schedule. Australia logs one of the first dramatic ground-based images, a frame where the tail threatens to run off the sensor edge. A day later, Spain and Chile add stacks with the same elongated geometry. Streak control becomes a practical concern. Exposures trimmed to keep the coma tight, then stacked by comet alignment to reveal length without blurring the head. Plate-solved fields confirm orientation. The tail points anti-solar as expected, while a fainter orbit-aligned dust feature hints at heavier grains lagging the path. What stands out is not just brightness, it's the combination of brightness, scale, and speed of community verification. Most new comets emerge as whispers close to the noise floor, needing large apertures and long integrations to pull from the background. This one announces itself. You do not need to push your equipment to the edge to record it. A modest lens on a tracking mount can trace its arc in a single nautical twilight session. Within the same window, another plotline is already on the whiteboard. 3i Atlas, an interstellar visitor inbound on a hyperbolic course. Different radiant, different geometry, different story. Yet the calendar boxes overlap. Perihelion predictions settle within days of each other. Swan around October 20th at roughly 1 astronomical unit from the Sun. Atlas around October 17th at a few tenths farther out. In three-dimensional space, their nearest approach to the Sun is separated by on the order of tens of millions of kilometres. Close in heliocentric terms, far in human terms. On the sky, their approach vectors are split by a wide angle arriving from different constellations. The odds of two high-profile arrivals sharing a narrow perihelion window are not zero, but they are small enough to make seasoned observers raise eyebrows. The geometry imposes a practical constraint. As both tracks curve inward, solar elongation shrinks. From roughly October 8th to 18th, the exact days depending on latitude, ground-based telescopes lose direct access in full darkness. The sun's glare and low altitudes create a blackout period for detailed optical work. Coronagraphs and heliospheric imagers can still see, most backyard rigs cannot. Planning calendars adjust. Teams front-load observations, then prepare to resume on the outbound legs. Comparisons begin to crystallize. Atlas looks compact, fast, and, if spectra cooperate, chemically interesting, with reports of unusual gas ratios under review. Swan looks big, bright, and persistent, with a tail that dominates wide fields and a coma that holds shape across nights. One behaves like a precise messenger, the other like a massive signal flare. Side-by-side rate plots show Atlas with higher sky motion near perihelion cross, Swan with the most photogenic extent for casual gear. Neither is on an Earth-crossing path, both are safe, both are rare in their own way. Numbers anchor the narrative. Tail length, degrees, not arc minutes. Peak integrated brightness, within reach of binoculars at dark sites. Position angle of the tail, consistent with anti-solar predictions within a few degrees each night. Apparent rate of motion, measurable drifts in arc seconds per minute, increasing towards the closest approach to the cud, then falling. Photometric behaviour. Brightening trend, consistent with decreasing R and delta, modulated by phase angle and dust properties. No single outburst defines the early timeline. The growth looks steady and geometric. Instruments respond. Some observers switch to non-sidereal guiding to keep the coma sharp and let stars trail. Others shorten sub-exposures and increase counts to prevent smearing at higher rates. Polarizers stay in cases. Broadband filters dominate to maximize photon throughput, except where light pollution demands compromise. Calibration becomes the difference between a pretty picture and useful data. Flats to tame vignetting across that giant tail. Careful background models to subtract twilight gradients near the sun. Verification remains a theme. Spectral claims get second and third looks. Magnitude estimates are tagged with aperture sizes and sky conditions. Orbital solutions from different pipelines are cross-checked for consistency. Heliocentric versus barycentric frames, with or without non-gravitational parameters where justified. The best fit lines converge as the observational arc lengthens. Uncertainties shrink from arc minutes to arc seconds on near-term predictions. Public interest climbs with the visibility. News outlets ask for the big picture. The honest answer is straightforward. A very large, very bright cometary object has entered the inner solar system on a path that makes it easy to see for a brief window. An interstellar object is arriving on a different path at almost the same time. Both are photogenic in different ways. Neither is a hazard. The overlap is unusual and worth everyone's attention. By the end of the first week, the logbooks are full. Timestamps in UTC, RA/DEC lists, sky brightness notes, moon separation, seeing estimates, plate stills and alignment choices. The frames themselves tell a clearer story than any headline. Night 1, a long, pale tail and a tight head near a modest asterism. Night 3, the same tail longer, the head brighter, The asterism shifted towards the frame's edge. Night 5, elongation dropping, altitude trickier, gradients higher, still a visible sweep of dust across the field. The object is not a rumour anymore. It is a line you can draw and a schedule you can keep. 3I Atlas is the third confirmed interstellar Vistron record, and everything about it carries the signature of once only. The 3I marks its place after 1I / Oumuamua 2017 and 2I / Borisov 2019. Atlas credits the survey that raised the first reliable alerts. The orbit locks the identity in place, a hyperbola eccentricity greater than 1, specific orbital energy positive. Far from the Sun, it coasts at a non-zero excess speed v infinity that gravity cannot erase. No capture, no loop, no second act. Inbound line, single bend at perihelion, outbound line. Simple on paper, rare in practice. Position measurements tighten the track night by night. Fit enough dots and the geometry steps forward from sketch to blueprint. A steeply inclined path that slices across the ecliptic rather than riding along it. An inbound radiant in a different sky sector than the big bright newcomer. A perihelion date landing within the same narrow window by coincidence or design. Early observers watch the residuals fall as the data arc lengthens. The uncertainty ellipse on future positions shrinks from "search this patch" to "point here." Apparent motion increases approaching the Sun, peaks near the sweet spot of distance and viewing angle, then tapers. It behaves exactly like the math says an unbound visitor should. Brightness follows geometry with small telling departures. As R, Sun distance, and delta, Earth distance drop, total magnitude trends upward, then stabilizes and slides back after the swing. The profile looks restrained compared to classic dust-rich comets. Frames often show a compact star-like head, sometimes with only a hint of a diffuse halo. Long integrations tease out low surface brightness structure, but the default impression is tight, fast, faintly active. This aligns it closer to Oumuamua than to Borisov in appearance, though it is its own case, neither purely inert nor classically dusty. Spectra and photometry seed debates that spread quickly across observing lists. One camp reports unusual line strengths, carbon dioxide stronger than expected relative to water, trace metals that don't split cleanly along familiar comet patterns. Another camp urges caution, calibration drift, sky subtraction, slit losses, and phase angle effects can distort early spectra at low signal to noise. Replications roll in from other latitudes, other instruments. Numbers begin to cluster. A cautious consensus forms around non-standard, but not yet unprecedented, and the outliers stay on watch lists rather than in conclusions. The interstellar label matters because it reshapes expectations. Born under a different star, processed by a different radiation field, ejected by a different set of planets, 3I Atlas is not obliged to mirror solar system comets in composition or activity. Its spin state could be tumbling. Its surface could be a welded crust with buried ices that vent only along certain facets. Non-gravitational terms, tiny accelerations aligned with the Sun or the object's velocity, are tested in orbit refinements. If the fit improves when those terms are added, subtle outgassing is present. If not, the track stays gravity clean and the whispers about control dissipate into better data. Observers adjust tactics to the object rather than the other way around. When apparent rate climbs toward arc seconds per minute, sub-exposures shorten to keep the head round. Stacks increase in number to recover signal. Comet rate guiding, where available, keeps the visitor centered, while stars trail into telltale dashes. Plate solving writes a world coordinate system into each frame so centroids can be measured precisely. No arguments about by-eye positions, just RA/DEC to arc seconds and UTC to seconds. Photometry logs include aperture size, sky annulus, filter bend, air mass, moon separation, and seeing. The paper trail is the science. Compared to the giant traveller with the spectacular tail, 3I Atlas feels minimalistic. That contrast is useful. Wide lenses that lavishly capture the long dust river of the bright comet will show Atlas as a small condensed feature. Medium and long focal lengths turn it into a viable target for careful imaging and measurement. Rate versus date plots make planning simple. Expect the fastest sky drift near the sun, tapering afterward. Expect the best SNR when altitude is highest and the moon is cooperative. Expect phase angle changes to nudge total brightness and any faint tail orientation. Safety, often the first public question, is straightforward. The missed distance from Earth is comfortable, the MOID is not in the red, and the orbit solutions are converging rather than wandering. Apparent speed on the sky is not a proxy for physical proximity. A fast streak in an eyepiece during good seeing can be millions of kilometers away. A slow, nearly stationary speck can be dangerously close if the geometry says so. Here, the geometry says passerby. The calendar clusters around a few practical dates. Early inbound weeks are for establishing the track, verifying spectra, and hunting for low-contrast coma. The perihelion window is for rate management and caution, shrinking elongation and higher background limit ground-based opportunities. The outbound leg is for refinement, cross-checking non-gravitational fits, testing whether brightness falls off symmetrically, and looking for any delayed dust that might seed a narrow meteor stream years later. Each phase has its own logic, and none require sensational claims to be absorbing. Context gives the visit weight. One-Eye/Oumuamua offered shape puzzles and a near-featureless spectrum, sparking years of arguments about ice, dust, and non-gravitational nudges. 2-Eye/Borisov looked like a comet's comet, gas-rich, dust-active, almost comforting in its familiarity despite its origin. 3-Eye Atlas sits between those two poles, more active than a bare rock, less flamboyant than a dust geyser, interstellar by energy budget, timely by accident. 3 data points are not a population, but they outline a triangle large enough to fit surprises inside. The mapping from orbit math to night-by-night experience is clear. Local sidereal time sets which RA strip is high when you can observe. Start at the same wall clock minute each night, and you'll sample similar hour angles. Start 4 minutes earlier per night, and you'll sample the same sidereal time, making the background star pattern match for cleaner blink comparisons. Log both. When the object is faint, control of time becomes a tool equal to aperture. Equipment choices matter in predictable ways. Fast optics, low F ratio favour surface brightness for diffuse comae. Large apertures favour Senar on compact heads. Pixel scale should match seeing so you don't dilute the signal. Under bright skies or in twilight, drop sublengths to avoid clipping and raise counts to claw back SNR. Sigma clip stacking tames airplanes and thin cloud. None of this is exotic. It's the ordinary craft of turning photons into facts. Estimates that flirt with the extraordinary, stepwise accelerations, composition claims far from the median, stay in play with labels. Provisional, needs confirmation, consistent across 2 sites, not reproduced elsewhere. The discipline is the difference between a gripping story and a durable result. If a feature is real, it will survive new data, new methods, and skeptical replication. If it fades, it was a processing artifact or a wish seen in noise. Either outcome teaches something, the public-facing summary remains calm. An interstellar object is crossing the inner solar system on an unbound hyperbolic path. It will not return, it is faint to the eye, visible to modest telescopes and cameras, and scientifically valuable because it samples materials and histories from beyond our sun. Its timing overlaps with a far brighter comet on a separate trajectory, an overlap that is unusual and visually compelling. Both can be observed, neither threatens Earth. The rest, the why now, the what does it mean, the is anything coordinated, belongs to later chapters and better data. Meanwhile, the work continues in small exact moves. RA/DEC lines fill tables, residuals shrink, spectra stack, rates smooth. The visitor crosses a handful of constellations, leaves a handful of folders on hard drives, and adds one more precise line to a graph that, A century from now, we'll show the first dozen, then the first 100 interstellar tracks. Tonight it is one more point on that future chart, and one more reason to step outside, let your eyes adjust, and remember that from elsewhere is not a metaphor here. It's a coordinate system with your telescope in it. It does not sneak in, it declares itself. A broad, luminous wake cuts across stacked wide-field frames and refuses to be mistaken for anything else. Early numbers land on the desk in fast succession, integrated magnitude in the sevens under dark sky, a tail stretching in degrees rather than arc minutes, position angles lining up cleanly with the anti-solar direction. The first plots look almost like exaggerations until more sites echo them. North America, Europe, Australia, Chile, same long linear structure, same condensed head, same steady brightening as R and delta fall together. What makes it different is scale at first sight. Most new comets arrive as soft smudges that need long focal lengths and careful stretches to pull from the background. This one draws a line you can measure with your hand at arm's length. 2.5 degrees of pale dust is not a processing trick. It is a ribbon of sunlight scattered by grains stretched across millions of kilometers. A 50mm lens on a tracked camera records it without strain. A small refractor turns the head into a tight, persistent core sitting at the base of an obvious fan. Where you expect to fight for signal, you find yourself instead managing gradients, vignetting, and frame size because the subject simply does not fit. Naming happens quickly and sticks. A provisional designation, then C/2025R2, then the SWAN tag in acknowledgement of the spaceborne instrument that spotted it. The pipeline from alert to common knowledge is short. Within 48 hours, public feed aggregators and private Slack channels are full of annotated cutouts, plate-solved overlays and photometry tables with honest error bars. The tone is crisp rather than breathless. Observers compare aperture choices and sky anomaly. They argue over whether a shallow gradient is twilight or a faint ion component. They line up synchrone and syndine overlays to test how the dust aligns with emission epochs and grain sizes. The answers are preliminary, the size is not. Perihelion predictions settle into a narrow band on the calendar. The path is steeply inclined, the ecliptic crossing is sharp rather than glancing. Solar elongation compresses as the date approaches, creating a practical window that moves imaging into the edges of night. Late dusk and early dawn become the workbenches. Planning turns pragmatic. Shoot high in altitude to limit extinction, watch moon phase and separation, accept shorter subs to avoid clipping in bright sky, and recover signal with numbers rather than length. For many, the tactic is new. Treat a comet like a bright nebula, fast optics, wide fields, careful flats, lots of sub, tight calibration. The results reward the effort. A single evening produces sequences that would normally take a week of clear nights to match. Visual observers get a rare gift. Under dark rural conditions, binoculars in the 7 times to 10 times class begin to show a faint elongated glow with a bright knot at one end. A small Doppelsonian at low power turns that knot into a soft head and hints at the fan. The emphasis is on expectations. This is not a searchlight in the sky. It is a low-contrast extension against a still bright background for many latitudes. Yet the fact remains, you do not need a large telescope to participate. For thousands of newcomers, this is the first comet that actually looks like a comet in their own gear, rather than a star that someone told them was interesting. The numbers stay disciplined. Photometry from different longitudes converges when corrected for air mass and filter differences. The integrated magnitude rises as the geometry improves, then begins to flatten near predicted peaks. Surface brightness remains the real constraint, just as it always does for extended objects. Imaging logs note seeing in arc seconds, sky brightness in magnitude per arc second squared, and the phase angle that quietly governs how dust scatters light into the detector. Sub-exposure times step down as the rate of motion increases. Total integration steps up to keep signal to noise on pace. Guiding at comet rate becomes common. Stars trail into small dashes that immediately communicate apparent motion without apology. Morphology develops beyond long tail, close looks reveal subtle structure, a broad dust fan dominating the visible, possibly a narrower, straighter feature from ionized species riding the solar wind at a different stiffness. Gentle kinks along the fan consistent with changes in emission rate and viewing geometry rather than dramatic outbursts. Position angle measurements night to night hug the predicted anti-solar vector within a few degrees. Synchrones plotted for successive days sketch curves that the visible fan follows with satisfying fidelity. If you prefer pictures to plots, blink 2 nights and watch the head advance while the tail reorients just enough to prove the geometry is real. Spectroscopy divides time between ambition and reality. Small aperture prisms and grisms pick up continuum slopes and broad gas bands. Large instruments chase specific emission lines and try to keep up with the comet's non-sidereal rate. Early claims get tagged as provisional. Replications trail by a night or two as weather and visibility permit. A cautious center forms. The object is dust-rich, photometrically generous and spectroscopically within reach of mid-size instruments. It is not a flat spectrum oddity, nor a feeble gas-only wisp. As always, the best practice is to publish methods as carefully as results. Slit widths, extraction windows, sky subtraction choices, so later teams can reproduce or refine the line ratios honestly. The overlap with 3i Atlas becomes a planning constraint and a narrative accelerant. Both are inbound, both reach perihelion within days, both pass through a period of poor ground-based elongation that forces reliance on space-based imagers for the exact moments you most want to see. One is a spectacular dust producer, the other a compact interstellar messenger with debated chemistry. Schedules split nights in 2. Wide-field runs aimed at the massive tail in the early evening, long focal length sequences aimed at the compact head of the interstellar visitor near morning. The calendar looks crowded, the sky looks generous. Safety remains uncomplicated. Misdistances are comfortable. MOIDS are not a concern. Published orbit solutions from multiple centres agree to within expected tolerances. What looks large on a photograph is not necessarily close in 3 dimensions, and the public explanations stick to that distinction. The right kind of reassurance becomes part of the script. There is wonder here, not risk. There is technique to practice, not a panic to feed. Outreach ramps naturally. Planetariums, school astronomy clubs, and public parks schedule comet evenings with realistic promises. You will likely see a faint glow and a stub of tail in binoculars. On the screen, we'll show stacked live views that reveal the full sweep. Live streams adopt non-sidereal tracking so watchers can see the head hold still while the stars drift. An instant, intuitive lesson in relative motion. People who have never cared about phase angle learn in 3 minutes why the view looks better at one time of night than another. The vocabulary perihelion antisolar elongation stops sounding like jargon and starts feeling like useful labels. Amateurs carry a surprising share of the scientific load. Wide-field monitoring catches subtle fan changes that professional telescopes, with their narrow views, would miss. Cross-hemisphere coordination closes gaps in the light curve. Plate-solved astrometry at arc-second precision, taken consistently night after night, sharpens orbit fits and gives non-gravitational terms a fair test. Public repositories for raw subs fill with usable data, calibrated frames with good headers, not just stretched JPEGs. The line between pretty picture and useful measurement stays porous in the best way. As the object nears peak accessibility, the practical challenges stack up and get solved one by one. Flat fields must be excellent to remove vignetting across a tail that spans much of the frame. Background gradients from twilight or urban glow need honest models, not aggressive curves that carve away faint structure. Focus must be maintained as temperatures slide. Coma correctors must be aligned. Tracking models need fresh sinks as hour angles change. None of this is glamorous. All of it is the difference between "I think I see it," and "Here are numbers you can reproduce." Then the geometry tightens further, and the sun's proximity wins for a time. Ground observers pause or shift to risky low-altitude attempts with conservative limits. Space-based coronagraphs and heliospheric imagers become the primary eyes. Daily movies show the head sliding past the occulting disk, and the tail reacting to the solar wind in real time. Data cadence increases even as access narrows. The handoff between platforms is seamless when planned well, and frustrating when not. The waiting becomes part of the experience. The comet is still there. You simply cannot look at it from here for a few days. On the far side of the window, the outbound leg begins. Brightness trends reverse, rates fall, elongation grows, familiar star fields return to accessible hour angles. Observers repeat early tactics in reverse. Longer subs as motion slows, wider fields to keep the tail within the frame, smaller apertures for integrated photometry as surface brightness drops. The emphasis shifts from spectacle to continuity. Long baselines matter more than one dramatic night. The best sequences will be the ones that show a clean rise, a clean peak, and a clean fade under similar methods. In the end, the giant arrival is not a single moment. It is a corridor of nights defined by numbers that agree across continents. A degree-scale tail that ordinary lenses can draw. A condensed head that holds its place against a rushing star field when you track at its rate. A schedule that bends your evenings and mornings just enough to remind you that the sky keeps its own time. The large-scale beauty is obvious. The quiet lesson is better. When a rare object gives you both accessibility and scale, you meet it with simple discipline. Point where the ephemeris says, expose within the limits the sky sets, calibrate without shortcuts, and share what you measured. The size does the rest. 2 paths, 2 origins, 1 narrow window. The charts stack on a light table and the geometry jumps out before the numbers do. One object descends from a high inclination track. The other cuts in on a hyperbolic line from a different quadrant of the sky. Their radiants are separated by a wide angle, their longitudes of ascending node, their arguments of perihelion, their inclinations. None of it lines up in a way that suggests shared ancestry. And yet the calendar does something improbable. Both curves thread the same slice of inner space within days of each other. It is not overlap in a loose hand-waving sense. It is a corridor, narrow in time, specific in distance, and inconvenient placed against the sun. Plot heliocentric distance versus date and the lines converge towards similar values in mid-October. Slide the same plots into solar elongation versus date, and the trouble appears. As they approach their closest solar distance, the elongations for ground observers collapse toward the glare. Their practical consequence is simple. The most interesting part of each curve occurs when most telescopes on Earth are least able to point. A blackout window opens and the corridor runs right through it. Lay the paths on the celestial sphere and the contrast sharpens. The dust-rich giant approaches with a steep tilt to the ecliptic, more than 60 degrees off the plane where planets parade. The interstellar visitor arrives almost orthogonal to that plane, crossing the planetary stage rather than joining it. On a star map, their approach vectors trace back through different constellations, separated by more than a quarter of the sky. No shared stream, no obvious broken parent, no simple 2 shards of one body story. Statistically, comets and visitors arrive scattered across months and years, perihelia spread like pins across a corkboard. Here, 2 of the decade's most watchable objects aim for the sun's neighbourhood together, threading distances that differ by only a few times 10 million kilometres, closer than Mars gets to Earth, while their inbound directions point far apart. Seasoned dynamicists call it interesting. Observers call it a gift with a catch. Time adds its own narrowing. Perihelion for one lands around October 20th, the other October 17th. The days in between are saturated with geometry, phase angles that favour dramatic dust scattering for the bright tail, sky rates that peak for the compact interstellar head, anti-solar position angles that swing quickly as the Sun-object-Earth triangle reshapes itself hour by hour. If you could watch without the sun, it would be a week of textbook demonstrations, how phase boosts surface brightness, how ion features stiffen under solar wind, how non-sidereal tracking turns stars into dashes while a target stays still. Instead, the corridor insists you plan around edges. Nautical twilight becomes viable time, dusk and dawn become laboratories. Everything in the middle is ceded to space-based instruments. Spacecraft fill the gap, but with rules. Coronagraphs and heliospheric imagers can stare through the glare, filming dust fans sliding past an occulting disk, while the solar wind paints invisible forces onto visible shapes. Their cadence is high, their fields are wide, their sensitivity favours large-scale structure. The price is tracking and access limits. Not every instrument can follow a fast mover at a steep rate. Not every observatory can point near the sun at all times, and visibility windows open and close according to constraints that have nothing to do with your sky. Still in the corridor, they are the eyes that do not blink. On the ground, planning shifts from "what can I get" to "what can I get when?" Elongation charts become as important as ephemerides. Air mass forecasts matter as much as seeing. You pencil in short sessions when the objects rise above safe altitude before the sky fades to blue, and again when the sky returns to grey and then to black. You pre-point mounts in daylight to known bright stars for a fast plate solve at the moment the target climbs. You set conservative sun avoidance limits so a blind slew cannot cross danger. You swap long subs for many short ones to keep histograms under control in a bright sky. You accept that the corridor is a negotiation, not a possession. The numbers that define the corridor are undramatic on their own and striking in combination. Perihelia within a 10-day window rather than months. Heliocentric distances near one astronomical unit for one, only a fraction more for the other. Approach vectors dozens of degrees apart on the sky. Inclinations that say separate stories, not shared parent. Rate of motion peaks that demand different strategies. Comet rate guiding for the compact head, wide field discipline for the immense tail. Phase angles that swing fast enough to change appearance from one twilight to the next. Elongations that slide below comfortable thresholds just when curiosity is highest. You rarely get all of these in the same week. The corridor hands you the full set and asks whether your habits can keep up. Community behaviour adapts. Observers divide roles. Wide field patrols monitor the dust giant's fan for kinks and waves. Long focal length stations log precise astrometry and tight photometry for the interstellar visitor. Radio and radar teams check feasibility and mostly bow out given distance and speed. Spectroscopy groups schedule slit times at the very edges of night, chasing emission lines before the sky brightens. Data pipelines set up 2 tracks in parallel, aesthetic composites for outreach and calibrated stacks for measurement, so the same photons serve both curiosity and rigour. Debate takes a predictable path. Some see coordination where dynamics points to coincidence. Others caution that the solar system is a big place, our sample is small, and clustering happens in any random process when you look at enough draws. The responsible phrasing sits in the middle. Vanishingly small is not impossible. Improbable is not designed. What is not in dispute is the practical reality for anyone looking up. The corridor exists on your calendar whether you think it means something or not. What the corridor teaches, almost by accident, is how many quiet assumptions sit under a good night. You notice how much your results depend on sun depression below the horizon. You feel how quickly a phase angle shift can boost or flatten dust brightness even when distance changes only slightly. You learn the cost of a moon too close to the action. You discover how 4 minutes of sidereal drift per day can accidentally land you at the same hour angle unless you schedule with intention. You realise that 1 degree of elongation lost to geometry is harder to fight than 0.2 of a magnitude lost to haze. There is also the safety lesson, basic but non-negotiable. A corridor near the sun is a corridor near hazard for optics and sensors. Software sun avoidance zones are set and not overridden. Slew paths are checked. Daytime alignment routines stop well short of trouble. No image is worth a scorched sensor or an eye. The corridor sharpens discipline the way a narrow mountain road sharpens steering. As the window opens, fragments of the full picture assemble from the different latitudes. Southern observers get a cleaner dawn. Northern observers get a better dusk. One site loses 3 nights to weather. Another fills the gap with a clear run. A space-based imager releases a short movie that shows the dust giant's fan flexing in the solar wind. A mid-aperture ground telescope posts a tight spectrum of the interstellar head just before sunrise. Put together, it looks like choreography. In truth, it is coordination. People and platforms adjusting to a geometry that does not care about convenience. When the corridor reaches its narrowest point, the feeling is not frenzy, it is focus. Exposure plans are written down. Sublengths are chosen for motion and sky. Flats are collected at twilight on purpose, not as an afterthought. Plate solutions are checked against Gaia. Time sources are synced to UTC. The best nights look calm because the hard choices were made on paper before the telescope moved. On the far side of the glare, access returns and the corridor begins to widen. Elongations climb back into comfort. The dust giant's tail shortens in wide fields. The interstellar head slows enough on the sky to make longer subs practical again. The same charts that tightened now relax, and observers who missed the first window get a second chance to contribute. The calendar no longer dictates breathing. It lets you choose your hours again. Looking back, the corridor reads like a sequence of practical constraints turned into a plan. 2 objects with distinct origin crossed inner space at similar times and similar solar distances. Ground observers were forced to the edges of night. Spacecraft bridged the gap. The community split tasks and stitched outputs into a whole. The odds were low. The execution was ordinary in the best sense of that word. Repeatable, careful, collaborative. Whether you prefer the language of coincidence or the language of pattern, the geometry does not change. A narrow passage opened. 2 travellers used it. We watched from the doorways of dusk and dawn. If there is a larger meaning, it will come from the measurements, not the mood. If there is only the quiet satisfaction of having met the sky on its terms, that is still enough. The corridor did not ask for belief. It asked for timing, technique, and patience. And it paid anyone who brought those 3 with a week of work that will sit happily on a shelf marked rare. The question splits cleanly. Are we seeing natural physics playing out at large scale? Or are we watching signatures that imply control, patterns, pulses, alignments that don't look like chance? Start with what is solid. Dust tails align with the anti-solar direction because radiation pressure and the solar wind push small grains away from the sun. Larger, older grains can trace a trail along the orbit because they respond more sluggishly. Brightness generally follows simple geometry. As the distances to the Sun, R, and Earth, delta, shrink, total reflected light rises. After perihelion, the curve falls. Phase angle modulates apparent brightness because the scattering properties of dust change with Sun-object Earth geometry. None of this requires intention. It's the standard playbook, and most of what's been recorded so far sits comfortably inside it. Against that backdrop, the anomalies get attention for a reason. Stepwise changes in apparent acceleration, measurable shifts in sky rate over hours to days, draw lines on plots that look like someone nudged the throttle. Spectra that hint at unexpectedly strong CO2 relative to H2O at moderate heliocentric distances raise Yukawa eyebrows because many comets tilt the other way near the inner system. Claims of unusual metal signatures, nickel dominant with weak iron, cut across ordinary condensation chemistry and push conversations toward outliers. Atypical parent environments, severe surface fractionation, or non-natural alloys if one wants to read far. Periodicities in tail directional fine structure, if they repeat with a clock-like regularity, invite the word a modulation, which is a short walk to control. A sober pass through alternatives is essential before any of that becomes more than language. Natural outgassing can be episodic. A rotating nucleus with discrete active regions presents different facets to the Sun. As those vents turn into and out of illumination, thrust vectors change. If the spin state is complex, a non-principal axis tumble, the timing between peaks can mimic engineered pulses without any machinery. Sublimation fronts for CO2 and CCO sit deeper than water ice. As solar heat percolates into a layered interior, volatiles can release in a stepwise fashion once they reach critical depth and porosity thresholds. Thermal cracking can expose fresh ice abruptly, creating short-lived jets that look like bursts. Dust jets, once launched, can alter local illumination via self-shadowing, creating feedback that appears rhythmic in coarse sampling. Measurement itself is a minefield for false certainty. Spectra near the detection limit are sensitive to background subtraction and flap fielding. A barely there line can appear or disappear with a small change in how the sky is modelled. Slit losses, when a fast-moving target smears partly out of a spectrograph's entrance slit, can bias line ratios, especially if the seeing disk and coma gradients differ between gas and dust. Broadband photometry mixing different filter sets across observers invites colour terms that masquerade as real variability, unless transformed carefully. Even astrometry, which feels like the firmest ground, can absorb tiny catalogue differences or clock offsets and spit out residuals that look like non-gravitational pushes when the culprit is a mismatched time base or an unmodelled atmospheric refraction at low altitude. Orbit fits allow a controlled test. Standard non-gravitational parameters, A1, A2, or 3, introduce small accelerations aligned with the Sun-comet line, the velocity vector, and the angular momentum vector. If adding those terms lowers residuals consistently across weeks and across independent datasets, you have evidence for asymmetric outgassing, not a dashboard. If residuals only fall for one observatory, or only during one short interval, the safer conclusion is a local systematic, not propulsion. True step behaviour should survive changes in plate solving catalogues, in centroiding method, and in the mix of topocentric sites. The best practice is to fit on disjoint subsets, by instrument, by hemisphere, by date, and confirm that the inferred accelerations agree within uncertainties. A real physical push will not care which camera watched. Composition claims benefit from the same discipline. Strong CO. 2, near 3 to 4 astronomical units is common. Strong CO2 dominating close to 1 astronomical unit is less common but not unheard of, especially for comets with surfaces sealed by crusts that limit water sublimation until cracks appear. Metal signatures in reflected light are notoriously tricky. Surface scattering can mimic metallicity without pointing to bulk composition. If the nickel versus iron oddity is real, you should see it reproduced with different instruments and extraction methods, and you should check whether it tracks phase angle in ways consistent with well-understood polarization and reddening effects. A single spectrum, even a handful, is a hint. A phase-resolved, instrument-diverse series becomes a case. Periodic tail twitches need context. Aeon features can kink on timescales of minutes to hours as the local solar wind environment changes. Sector boundaries and transient streams sweep through, tugging charged particles into new curves. Dust features respond more slowly, smeared by inertia and grain size spreads. If the apparent cadence of tail changes matches known as solar wind variations, the safe reading is space weather, not steering. If the cadence follows the object's rotation period, which can be measured via light curve analysis, then jets plus spin suffice. A pattern that holds phase coherently across changing geometry, immune to spin and wind explanations, would be more unusual and worth stronger language. Timing coincidences belong to statistics, not intent, until proven otherwise. 2 bright arrivals in a narrow perihelion window are rare, but not impossible. Survey coverage, selection bias, and human attention amplify the impression. We notice and remember overlaps with spectacle far more than quiet, isolated passages. A robust way to test too unlikely is to frame the prior, given the historical discovery rate, sky coverage, and brightness distribution. How often would two high-visibility objects land within plus or minus 5 days by chance over n years? If the answer is once per few decades, that is surprising, but not in the realm that demands a new category-like coordination. The engineered reading suggests tests that natural stories don't require, but can pass. Look for course changes that are inconsistent with known non-gravitational forces in both magnitude and direction, accelerations-oriented counter to expected sublimation thrust, sustained over days without correlating to distance or phase. Search for spectral features that match manufactured alloys, or narrowband emissions inconsistent with any known gas. Examine light curves for highly coherent narrowband modulations across multiple bands that would hint at artificial beacons rather than tumbling or jet-driven flicker. Check for anomalous thermal behavior in infrared, temperature-distance relationships that ignore energy balance, implying active heat transport rather than passive absorption and re-radiation. Each of these has natural pitfalls. Coatings can alter thermal emissivity, dust can mask a nucleus, rotation can create quasi-periodic signatures, but a pattern that crosses several of these tests is harder to wave away. Transparency in the pipeline is the guardrail. Publish raw and calibrated frames when feasible, document reduction steps, specify catalogs and time sources, and share code or at least parameter sets for orbit fits. Invite adversarial replications. Ask groups that disagreed last time to try again with your data and their methods. If a claimed step acceleration survives a team specifically trying to refute it with careful controls, it is stronger. If it evaporates under different flats or a better clock, then the field learned something and moved on. There is also the human factor. Ideas that carry drama, fortress objects, rendezvous corridors, deliberate timing, spread fast because they are memorable. Natural explanations spread slowly because they are made of details. In practice, both can occupy the same table until data forces a choice. The discipline is to keep the language proportional to the evidence. Consistent with is honest. Proves belongs at the end, not the middle. If the balance were to tip toward design, it would not be because one number looks strange on one night. It would come from a portfolio of signatures. Persistent, repeatable accelerations misaligned with solar-driven thrust. Spectral lines that resist natural interpretation across instruments. Thermal behavior that refuses energy balance models. Morphology changes that keep time with an internal clock rather than with rotation, distance, or wind. And, crucially, cross-validation from independent groups with different gear and different biases. Short of that, nature with structure is the sensible default. Layered interiors, anisotropic vents, point-driven geometry, and solar wind choreography, all filtered through our sampling and our instruments. Meanwhile, the work that answers the question looks the same either way. Track precisely. Fit orbits with and without non-gravitational terms. Gather spectra across phase angles and distances. Measure polarization to constrain dust microphysics, log cadence in light curves to fish out rotation periods, and coordinate ground and space coverage to bridge the corridor near the Sun. Whether the verdict lands on nature or design, the path there is measurement, replication and patience, not proclamation. There is a quiet advantage to holding the question open. Natural explanations sharpen as they are forced to account for every wiggle in the data. Engineered hypotheses become testable when they commit to predictions rather than aesthetics. Either outcome leaves the field stronger. New compositional corners mapped, new reduction pitfalls documented, new coordination habits between amateurs and professionals made routine. The sky is generous in this way. It gives you an anomaly and lets you decide whether to turn it into a story or into a study. The better choice most nights is the study. The story then writes itself, later, clearer and true. Safety is the easy part. Neither object is on an Earth-crossing trajectory, and the orbits, fit from many nights of astrometry, show comfortable misdistances. In planetary defence practice, analysts look first at the MOID, minimum orbit intersection distance. A small MOID can flag potential close approaches over long timescales. A large MOID rules them out. For these visitors, the MOID is not in a regime that warrants risk watches. The orbit solutions are not wobbling from day to day. As more observations arrive, the uncertainties shrink and the predicted sky positions converge instead of wandering. That convergence is the quiet fingerprints of no surprises ahead. Gravitational influence is a non-issue at these separations. Tidal effects fall with the cube of distance. A small body many millions of kilometers away has no measurable tug on Earth's oceans or crust. Electromagnetic effects aren't a mechanism here either. Space weather that matters to us, auroras, satellite charging, comes from the sun, flares, CMEs, not from comets. Even if dust is released near the sun, it expands into an extremely diffuse cloud. Column densities are so low that years later, the most you might notice, if Earth ever intersected a filament, would be a mild uptick in meteors. Pretty, not hazardous. Apparent speed on the skies is not a proxy for danger. Objects can scud across a camera frame at several arcseconds per minute while being tens to hundreds of millions of kilometers away. Conversely, a slow creeper could in theory be near. Here, the range and geometry are known. The hyperbolic nature of 3i Atlas, interstellar unbound, guarantees a single swing and exit. The long-period comet's ellipse is large and leisurely. No resonances with Earth, no keyholes that matter for us along the measured path. Brightness and size do not imply proximity. The giant tail looks dramatic because of surface brightness but spread over degrees of sky and a prodigious dust output, not because the nucleus is nearby. Integrated magnitude can be within binocular reach, while the object itself is comfortably distant. Think of it as sunlight painted on very fine powder suspended along a vast curve. The paint is bright, the brush is far away. The main operational risk is to telescopes, not to people or planets. Small solar elongation can place a slewing instrument perilously close to the sun's line of sight. The rule is simple. Set hard software sun avoidance limits, use horizon masks, and never override them while chasing a low elongation target. A single accidental exposure near the sun can wreck a sensor. For visual observers, the same caution applies. No searching near the sun without proper certified solar filters firmly mounted. Never sweep optics through daylight sky hoping to find a comet. Plan point-ins with ephemerides and wait for safe altitudes. If you go out to look, expectations help. Most people will not see a spectacular naked-eye searchlight. Under dark rural skies, a degree-scale dust fandel can become a faint glow in 7 to 10 times binoculars, an elongated haze with a soft knot at one end. A small telescope at low power shows a condensed head and a broader fan if sky brightness and phase angle cooperate. Urban and suburban skies wash out low contrast structure. Imaging wins there. Cameras trade time for photons. Many short sub-exposures stacked carefully will reveal more than the eye can hold in one moment. Good planning beats big gear. Pick windows with the comet above 25 to 30 degrees altitude to reduce air mass and extinction. Avoid strong moonlight or keep moon target separation large. If the object's apparent rate is high, shorten sub-exposures to keep the head round and increase the number of subs to keep SNR. If your mount allows non-sidereal guiding, track at the comet's rate. The head stays sharp, stars become tasteful dashes that immediately explain the geometry to anyone watching. Capture good flats, long tail spans vignetting and gradients that sloppy calibration will mistake for structure. Personal safety at the site is ordinary and practical. Red lights low and dim to preserve dark adaptation. Trip hazards taped or tucked. Batteries warm, cord strain relieved. If you use a green laser for outreach, respect local regulations and keep it out of air lanes. Dress warmer than you think. Fatigue and chill make poor decisions more likely. Let someone know where you are, especially for solo rural sessions. Astronomy is patient work. Your setup should be quietly forgiving if you get distracted by the sky. Questions about capture come up every cycle. Capture of an interstellar object by gravity alone is extraordinarily unlikely. You need to remove energy to drop below solar escape speed. Gravity on its own rearranges direction and speed assists. It doesn't dissipate energy. Absent a deep atmospheric pass or a razor-tuned three-body encounter, an interstellar body remains unbound. The expected story arrive, bend, depart holds. Concerns about targeting Earth usually arise from sky maps that show icons near constellations or planets. That proximity is a projection, like two airplanes that look close from the ground while flying at different altitudes. The numbers that matter for proximity are delta, distance from Earth, and MOID, not an arrow passing a bright star on a chart. When those numbers say far, the picture is reassurance, not alarm. If you're imaging near the corridor of small elongation, keep exposure histograms out of saturation. Bright twilight backgrounds will clip fast. Many short frames avoid blowing out the sky while still collecting enough photons to stack. Use sigma-clipped integration to tame satellites and thin cloud. Plate solve early and often so your field truly covers the predicted RA/DEC. Trust coordinates, not memory, when the sky is bright. On the human side, clarity helps everyone sleep. Saying distant, safe, beautiful is not spin. It reflects the measured path, the missed distances, and the physics we use every day. The sun is the active player in this drama. We are spectators on a moving platform. What we learn from these visitors, dust physics, volatile behaviour, interstellar sampling, does not require threat to be meaningful. There's a lingering worry that dust streams might later intersect Earth and produce something more than meteors. Cometary debris typically disperses into thin filaments with extremely low mass density. If a stream ever aligns with our orbit, the effect is a meteor shower, not a sandblaster. Spacecraft operators watch for enhanced micrometeoroid environments. Everyday life does not register the difference. If you want a single practical checklist that keeps the night easy, 1. Verify time to UTC accuracy, NTP on. 2. Use topocentric ephemerides for your exact site. 3. Set conservative sun avoidance and horizon limits. 4. Plan for altitude and moon separation. 5. Choose sublengths based on rate of motion and sky brightness. 6. Collect proper calibration frames, bias, darks, flats. 7. Stack with care and annotate with WCS. 8. Log condition so your future self understands changes in brightness or morphology. Follow those, and the only risk it is losing track of time because the view is quietly absorbing. In the end, safe means the orbits are measured and missed distances are healthy. Distant means the scale is astronomical, even when the photo looks close. Beautiful is what's left when anxiety is removed. The sky offers rarity without peril here. A giant dust fan you can trace with ordinary gear, and an interstellar traveller that turns math into motion and then into a clean goodbye. Enjoy it on its terms, without urgency, without fear, with the kind of unhurried attention that makes faint things reveal more than you expected. What remains is a set of habits, a few numbers that make future nights easier, and a calm understanding of scale. You keep the ephemeris discipline fresh before each session. Note whether the entries are topocentric and of date. Write down RA/DECC with enough precision that small motion shows. You keep the clock hygiene, UTC sync on, time zone, and DST checked. A quick glance at local sidereal time so you know which right ascension lives on your meridian when you step outside. You keep the muscle memory of framing, wide when the subject is large and delicate, long when it is compact and fast, always with flats that match the optical train so gradients don't lie to you. From the data, a quiet library forms. Light curves with honest error bars. Rate of motion plots that tie apparent drift to geometry. Polar plots of tail position angle against the antisolar vector. A folder of spectra, even if modest, labelled with slit width, air mass, and extraction apertures. fits headers that actually tell a story. Plate scale, pixel size, temperature set point, sky quality notes, moon separation, and seeing. None of it is spectacular in isolation. All of it is useful later, to you or to someone else who wants to understand what changed and what did not. You keep the workflow that turned brief windows into reliable outcomes, pre-pointing a mount before astronomical darkness, plate solving early so the field is true, then syncing the model, choosing sub-exposure lengths from rate of motion rather than habit, watching histograms near twilight and shortening subs before clipping arrives, annotating frames with UCS so every pixel has sky meaning, stacking twice when it matters, once star aligned for familiar fields, once comet aligned to honour the moving subject, saving the linear masters even if you enjoy a stretched version for sharing, writing a line or two after each session that your future self will understand without reopening the files. On the human side, what you keep is a better sense of proportion. A degree-long tail is not an omen. It is sunlight on dust, spread thin across space made visible by patience and optics. A fast-moving head is not pursuit. It is geometry and an unbound orbit doing what the equations say. You learn to separate the shock of a picture from the calm of a plot. The picture pulls you outside, the plot keeps you honest once you're there. Both matter, but not in the same way. Rituals survive because they work. A thermos in the bag because clear nights surprise you. A list taped to the SAR case, dew control, power, cables routed away from axes. Focus before you care about anything else. A small red light that is genuinely dim. A habit of pausing before slews near the sun, even when software is configured, because caution is not redundant in this part of the sky. A rule to stop when fatigue arrives and the last exposures are worse than the time it takes to close down. The sky will not run out of nights. You will run out of attention if you don't guard it. Community is something you don't plan for and then realize you have. A message thread where observers on 3 continents compare plate scales and agree on aperture settings for photometry so numbers add instead of fight. A shared folder with raw subs that someone else stacks better than you did because their gradient model fits your lens, vignetting more cleanly. A small concession to consistency, using the same catalogue, the same filter band, the same centroiding method, so your piece fits their pieces and the whole becomes a record robust enough to outlive social feeds. You keep that because the next rare thing will arrive on its own timetable, and you will want to remember how to move together without rehearsal. You also keep the clarity that natural versus engineered is not settled by metaphors. If the anomalies soften under better calibration, you accept it without drama and update your notes. If some survive and replicate across instruments and sites, you tighten your methods and push the tests that distinguish mechanism from mood. You keep language proportional, consistent with, suggests, requires confirmation, survived adversarial replication. That vocabulary is not modesty, it is accuracy, and it lets the next paragraph be trusted when the evidence gets stronger. The practical lessons fold into everything else you observe. Sidereal time becomes a tool rather than a trivia fact. You shift sessions by 20 to 40 minutes on purpose when you want a different hour angle, or match the sidereal minute when you want a clean blink with the same star pattern. Phase angle stops being an afterthought. You can feel how it lifts or flattens dust without reaching for a model. Elongation charts sit next to your weather app because both determine whether a plan is feasible. You start to plot rate of motion versus date for any moving target, not just comets, because exposure, length and guiding strategy should come from that curve, not from habit. From the experience of a narrow corridor near the sun, you keep a healthy respect for constraints. You set conservative avoidance zones and never override them. You pre-compute safe slews and practice them when the star is bright and the sky is forgiving. You give yourself more margin than you think you need, because you've watched histograms sprint upward in twilight and know how quickly almost fine becomes overexposed beyond recovery. It sounds like caution, it feels like competence. You keep an appreciation for surface brightness as the quantity that decides what is visible and what is not. Integrated magnitude is a noisy promise for extended things. What your eye and camera record is photons per square arcscan, balanced against sky background, optics, and sampling. That understanding turns frustration into planning, faster systems, better flats, darker windows, longer integrations of many short subs, and honesty about what a given site can deliver. When it works, you know why. When it doesn't, you know why too. There is a less technical list you keep because it turns out to matter just as much. The sense that calm attention is productive, that blinking 2 frames will teach you something your memory will distort. That saving the linear stack and the processing notes is a gift to the future you, who will forget how that nice image was made. That sharing a raw file instead of a finished picture can be the difference between a story and a measurement someone else can verify. That asking what would prove me wrong is not discouragement, is the move that lets your next claim survive a better version of yourself. You keep humility as a method. The sky does not bend around our narratives. It offers data at its own pace, hidden by glare when it chooses, available at edges when we're willing to meet it there. The corridor taught that by scheduling you, not the other way around. In exchange, it gave nights where a small lens recorded a structure millions of kilometers long, and mornings where a faint head held still while stars streamed by because you told your mount to follow the traveller rather than the background. Those are not tricks. They are ways of seeing that are now yours to reuse. Finally, you keep a few anchors that help when the next alert pings. A checklist that starts with time and ends with flats. A short note on how you decide sub-length from rate of motion and sky brightness. A template for night logs that has fields you actually fill. A favourite target altitude that balances air mass against practical session length. A reminder that surprise is not a plan, geometry is, and a line, written somewhere you will see it before you go outside, that says what these sessions are for, to turn faint, passing things into clear, durable knowledge, and to let that work steady your hours. When the headlines fade and your folders remain, what you keep is a practiced way of paying attention and a few tools that make the attention accumulate into something transferable. The objects that sparked it are already farther away than they were when you first read their names. That is fine. The point was never to hold them. The point was to learn how to meet the next one with the same quiet confidence. Set the coordinates, mind the clock, respect the light, write it down, and let the sky finish the sentence. And that's where we'll leave it tonight. 2 travellers crossing the inner sky, a narrow corridor of time, and a handful of numbers that turned into something you could feel. If you've been listening with the lights low, let your shoulders drop a little more. Unclench your jaw, breathe in slowly through your nose for a quiet count of 4, hold for 2, and let it go for 6. Again, a little softer this time. The night will carry the rest. Thank you for spending these minutes with me. I know you could be anywhere, scrolling past a dozen loud things, but you chose a calm corner and a slower story. That choice matters. It changes how the day ends. If tonight's wander helped you settle, tell me where you're tuning in from before sleep pulls you under. A city, a country, a balcony with a stubborn breeze, whatever here looks like for you. I love seeing that constellation of places fill the comments. Tiny pins of light from every direction. If you'd like more quiet astronomy when you need it, you can tap subscribe and the little bell. It helps this channel keep going, and it also means the next time you want a gentle drift through the sky, something will be waiting, already cued, already soft, already paced for breathing. If you're listening with your eyes closed, don't move, you can do it later. Rest comes first. A quick recap you can hold like a small stone in your hand. These objects are distant, their paths measured, their visit brief. They pass, we learn, and life on Earth continues at its familiar scale. That's the rhythm I hope you felt. Curiosity without urgency, wonder without worry. The universe is not asking you to keep up. It's inviting you to look up when you can and to rest when you can't. If something from tonight stuck with you, a number, a phrase, a mental picture of dust glowing in sunlight, Drop it in the comments tomorrow. Your notes often become the seed for the next episode. The question you asked about coordinates, the trick you shared for catching a faint tail in bright skies, the tiny ritual that makes your backyard feel like an observatory. This channel is a circle more than a stage. Your voice is part of the calm. For those who like little closing rituals, here's ours. Place one palm on your chest, the other on your belly. Feel the top hand rise just a touch, then let the lower hand do most of the moving. Slow the breath. Let the room get a shade quieter. Notice the simplest things, the weight of the blanket, the temperature of the air on your cheek, the way your eyelids relax when you don't ask them to. If thoughts arrive, let them pass like satellites in a long exposure, present, moving, not a problem. If you're still awake and want to drift deeper, I've queued a companion piece after this. Another soft voyage, different sky, same quiet pace. You don't need to pick anything, just let autoplay carry you. If sleep arrives before the first line, that counts as success. Your body knows what to keep and what to set down. For the night owls who enjoy a tiny practical note before lights out, tomorrow's sky won't be the same, but it will rhyme. If you find a moment, step outside after dinner or before sunrise and see which part of the star map has slipped westward by those silent 4 minutes of sidereal time. It's a small, reliable magic, one the world has used for centuries to measure seasons and patience. Then come back inside, warm your hands, and keep the rhythm you set tonight. To everyone who supports this channel by watching, sharing, leaving a kind word, or just letting a playlist run while you drift, thank you. It keeps the lights on and the pace unhurried. If you want to help steer future topics, there are gentle ways to do that in the description, but there's no pressure. Your time here is already generous. I'll be here next time with another calm chapter. Maybe why twilight holds colours without names. Maybe how a comet's dust tells time. Maybe just the simple comfort of the moon's slow cycle. Until then, keep a small place for wonder in your pocket. You can take it out when the day runs too loud and trade it for a minute of sky. One last breath together. Slow in, slower out. Let the edges of the day soften. Let the universe keep watch. Good night, Sleepy Voyager. Clear skies, gentle dreams, and everything you need waiting for you in the morning.